So let's look at how the quantum mechanical model explains a bunch of stuff. Chemical properties of the elements are periodic because the number of valence electrons is periodic. If you look at elements in the same column, they have similar properties. That's how the table got set up in the first place. They have similar properties because they have the same number of valence electrons. The number of valence electrons and the types of orbitals that they occupy are also periodic, and they follow the shape of the periodic table. I'm going to look briefly at some different families here. So the noble gases. The noble gases, except for helium, all have 8 valence electrons. So this is the S room and the P room completely full. For helium, there's only 2 electrons in there. That first floor only has 1 room, and it's completely full. Having that completely full is a bonus. It's more stable. So these guys are very inert. Helium and neon, I'm not sure that there are any known compounds for helium and neon. And these guys don't make compounds much at all. Yeah, so that electron configuration is especially stable, and that's why the elements are unreactive. If we look at the alkali metals, the alkali metals are actually very close to the noble gases, because really the periodic table should be a cylinder with a spiral just going around. Because why is there a jump between neon and sodium? It's 10 to 11. It's like when we take a map, right? We make it flat. But is the Earth flat? No, it isn't. It's not flat. It's a sphere, right? But it's not practical to be running around with a globe in your pocket all the time. And so we can't have a circular version of the periodic table. It's not practical. But sodium is actually just has 1 electron more than neon. Well, neon is especially stable. Sodium is especially unstable. When sodium reacts, it loses an electron. When it loses an electron, it then has the same number of electrons as neon. It doesn't become neon because it still has an extra proton. But the electrons are in the configuration of neon, and so that is more stable than sodium with that 1 extra valence electron. So it will react very easily to form an ion. And that's true of all of these guys. They will lose 1 electron, and in doing so, they have an electron configuration the same as the previous noble gas. The halogens are on the other side of the noble gases. They have 1 electron less than the next noble gas. The halogens are quite reactive. They tend to gain an electron. So let's look at chlorine. Chlorine has 7 valence electrons. We know, just from learning patterns, that chlorine forms a -1 ion. It gains an electron. When it gains an electron, it's got the same number of electrons as argon, and they're going to be in the same configuration, and that's especially stable, and that's why chlorine gains an electron and forms a -1 ion. And so that's true for all of these guys. Metals and nonmetals, many of them will form only 1 ion. The predictable ones, we've talked about those. So group 1A forms +1, group 2A forms +2, group 7A is -1, group 6A -2. The reason those are predictable is because when they gain or lose that particular number of electrons, they have the same number of electrons as a noble gas, and that's extra stable. So we have the noble gases over here, and these are the elements that form predictable charges. They screwed up here because hydrogen isn't up there, and so yeah, they numbered it wrong. So you might want to fix that. So fluorine likes to gain 1 electron to be like this neon, right? Oxygen needs to gain 2 electrons to be like neon. Nitrogen needs to gain 3 electrons to be like neon. Sodium loses an electron to become like neon. Magnesium loses 2, aluminum loses 3. Why aren't there any predictable ions here in group 4? They're kind of stuck in the middle. They have to gain 4 or lose 4. Either way is just too much trouble. Okay, so here's a different analogy I have. Back to high school. So the noble gases are the in crowd in high school. Those are the people that everybody wanted to be like, right? And the way most people approach trying to be in the in group, I mean, the first thing you can do is you can dress like them and act like them, right? That doesn't mean that you're one of them. You might still not get invited to the cool parties, but you can look like them. Well, for atoms, what's on the outside like their clothing? It's the electrons. So they can change the number of electrons. So fluorine could put on an extra electron and look like neon. Doesn't become neon, though, because the number of protons, who he is as a person, his personality is still the same. So he's not a noble gas, but he can look like one from the outside. Oxygen has a little more work to do, has to gain 2 electrons. Nitrogen has to gain 3 electrons. Carbon is just like, it's hopeless. I'm just a nerd. I'm just going to be okay with it. Okay, so those guys in the middle. But all of these, they are just changing their outside, the number of electrons, so that they can be like a noble gas. And that's why all of them have those charges. Any questions? So this is all of that in words, basically. Anions are formed when a nonmetal gains enough electrons to have 8 valence electrons. So looking at sulfur, here's the electron configuration for sulfur. It has 6 valence electrons. It wants 8, because that's what the noble gases have. So it'll gain 2 electrons. Now we have 3p6. It's got the same electron configuration as argon. It's not an atom anymore, though. It's an S2- ion. With the cations, they lose electrons. Losing an electron is always an endothermic process. They're not just throwing their electrons away. You have to put some energy in to pull them off, but they're very easy to convince. So here's magnesium. Its electron configuration has 2 valence electrons. So if it loses those 2, bam, they're gone. Now it has 8 valence electrons. And so that's a magnesium 2+ cation. It's got the same electron configuration as neon.